Hi, this is Ivan Shao and Chang Chen. Our final project is to prototype an elder care checker. Here is our prototype. Our product mainly includes two types of sensors, GPS and the IMU, which is Inertial Measurement Unit, MPU 9250. As you can see, the MPU is connected to the ESP32 via the I2C protocol. For the GPS sensor, instead of using the external GPS sensor, we're using the Blink app to access the smartphone's GPS module and get the corresponding GPS coordinates. Here are the Python files that we're gonna use to run our project. Besides the boot and the main, the rest of them needs to be copied and flashed into our ESP32. Boot file is used to connect the Wi-Fi. Here I use my phone as the hotspot. In the main file, we are doing a couple things here. The first part of the main.py is check the Wi-Fi connection and connect our ESP32 to Adafruit server. And then the code config the wait on motion and prepare the alarm message. Also, they're doing some initialization of MPU 9250 and also the Blink app. One thing we would like to mention is that we can use this code to calibrate the sensitivity to the point where the sensor can be triggered at the falling point but not the regular motion. Next part of the code. ESP32 is allowed to read the GPS coordinate from the smartphone by using the Blink app. Then it will publish the data to the Adafruit feed. Before it sends the data, ESP32 always store the data into the text file. Well, let's demonstrate the function. Since the ESP32 is connecting to our computer, so we need to run the boot.py to connect the Wi-Fi. And then it's the main.py. Well, as you can see right now, our ESP32 has been connected to the Wi-Fi and the Adafruit server, and waiting for the coordinate information from our iPhone. So once the ESP32 published to the feed, it will automatically go to the deep sleep mode. The location coordinates are able to see in our data feed, since our ESP32 published the data in a certain format. Therefore, the data will automatically plug into the map dashboard. For our video purposes, we switch the deep sleep mode to 30 seconds. So now, our ESP32 has been wake up and try to send the other location to the feed. But what if right now I apply 1G's acceleration to the ESP32? Here we go. The ESP32 has been wake on and then send the alarm message to the alarm feed. Connecting the Wi-Fi. Here we go. It has been sent to the alarm feed. Let's take a look. Once the feed receives the fault detected message, IFTTT will generate a notification email sent to the user. Let's take an example from our real world.